what's how difficult? So there's like when there's two people, there's also a third person that's the AI part, the some level of automation, like autopilot, maybe even.
That's correct.
Maybe you can kind of talk about the psychology of like you said, making decisions really quick, 80%. How do you deal with another brain working with you? And then also the automation. Is there an interesting interplay that you get to learn? And also as that changed throughout your career, I imagine it gotten better in terms of the automation, or perhaps not.
Well, I can tell you. So that let's.
Sorry, there's
let's,
a bunch
let's
of
start
questions.
this. No, this is good. This is good, and this is I'm enjoying this because now we actually get to talk about something other than a Tic Tac. So, so let's start with the A6. The A6 was really an analog airplane that was built in the '60s. All right, and there's been studies done on the crew coordination, which is the interaction between the pilot and the bombardier navigator. So we would fly low at night in the mountains. So I was stationed up in Whidbey Island, Washington. So you've got the Cascades and incredible amount of time. And we would get in the simulators because unlike normally people think terrain following, and there's the radars, the 111, the B1 has a system like this, but the radar can see and it'll fly. It basically flies a straight line. So it goes up and over mountains and back down and up and over mountains, where the A6 was really manual. So you do this low-level routes where you're gonna fly in the mountains at night. You're gonna be at 500 to 1,000 feet above the ground, ripping through like fog layers because you don't need to see outside. You're literally flying a little TV screen and a radar.
What are you looking at most of the time? So you just at a screen.
It's this really primitive. If you look at it now, what we did, you'd think, wow, that was crazy, but it was really fun. So
is it similar to like the FLIR stuff?
No?
This
thing is totally radar based. Now the airplane had a FLIR ball, it's target recognition and multi-sensor. It was called a TRAM.
You're looking at like basically like dots of hard objects.
No, actually, what it is the bombardier navigator had a radar, and he was getting raw feed off of a pulse radar in front. Okay, so it's just basically mapping the mountain. So if you look at a mountain on a radar and you're coming up on it, the front side is going to give you a really bright return, and then the back side, it's just going to be a giant shadow because you can't see on the other side. So the bombardier navigators would do that, and they would have charts, and they could shade their charts knowing that, hey, if we turn a little bit left here, we can get in this valley, we can sneak up this valley and then go around the back side of the mountain, which is what the airplane would do.
And sorry to interrupt. I'm going to just keep asking dumb questions. I apologize. But the pilot, can you at a high level say what the pilot does versus the bombardier?
Yes. So
you're actually just control.
I'm flying the jet. I have the throttles, the stick, and I have it's about probably a 4-inch or 6-inch wide by maybe 4 inches, 5 inches high. It looks like it's literally a CRT. That's how old it is. A CRT screen. And what the radar would do is the bombardier navigator is looking at his radar, and he's looking out about 12.5 miles in front of the airplane. So he has the range really scoped down because the radar can see a lot further. He's looking at about 12.5 miles when we're in the terrain mode where we're dodging mountains and stuff. And what the pilot has is they're called range bins, and there's 8 of them. So the very far range bin is the 12.5 mile, and the closest range bin, it's a thing, and it'll be like between like a half a mile or a quarter mile to 3/4 of a mile. And the next one might be 3/4 of a mile to 2 miles. And then it just keeps going out like that. So if there's a mountain in front, let's say we're on a flat plain and there's a mountain out in the distance at 15 miles and we're just driving right at it. So when we get to the point where it hits 12.5 miles where the radar is going to see it on his scope, my range bin for that would pop up and it would show like a big bump, like a mountain. Mm-hmm. And then as I got closer to it, the next range bin would pop up and show it. Mm-hmm. And I could see that bump was moving towards me. And then if I turned a little bit, to go over here, I'd see the mountain go over to the right-hand side and I could do that. But it wasn't like a video game. It's literally like, if you think of the original Ataris.
Yeah. But you build up, I imagine, that you start to get a really deep sense of like the actual 3D environment based on that little Atari style display.
You're exactly right. And you have to train. So there's been studies, as a matter of fact, a lot of the basis, and people will probably argue with me, but it's true. There were studies done watching A6 crews in our simulators. We called it the WIST, the Weapon Systems Trainer. And it was not even a motion. It just kind of sat there and you could fly these things, and they had terrain that they would inject into the system. But the crew coordination. So my first fleet bombardier navigator, I'll name him. His name's Chris Sato. He's works at Apple, pretty high up, MIT grad. Awesome. I think computer engineering. He's scary smart. So Chris could really work. As a matter of fact, all the guys I flew with, so there's another guy, Matt, who also worked at Apple, who's now at SAP. We did our first night traps together. The bond between us, I mean, it's one of those things that you're never going to forget. But Chris and I, when we started flying together, and we were actually the most junior crew in the squadron, we'd spent a lot of time training, and Chris was amazing at how he could work the system. One, because he was extremely brilliant, and he had that inquisitive mind of, we could do all these different things, and there's all these degradation modes. But we spent a lot of time to see how good we could actually get, because, and it's, you almost talk in partials. So as the BN is looking at his radar scope, Chris would say, I've got rising terrain. That's just what they say, showing rising terrain at 12 miles. And I'd see the little bump and I'd say, got it. This is going to go to your question on the autonomy and how you work with two heads.
Yes.
So when you first get together, the interaction, it's almost like you have to rehearse it. You have to know, and you talk in full sentences. The more and more we fly together, Chris could go, I'm showing, and he'd get like rising out. And before he finished, I'd say, I've got it. So you end up starting to talk in partials, because I have to trust him. Like, I mean, I can have no doubt that he knows how to do his job, because I'm literally looking at this little scope that's not giving me this continuous picture of that mountain moving. Remember, the mountain's here, and then it's going to pop up here, and then it's going to pop up here, because there's gaps in the coverage on how the system was set up. Remember, it's an analog system, to where he is telling me, like, I can't see all the way to the left, and he's got a wider scope on the radar, but my screen doesn't show that. So he's telling me, start a left turn.
How to avoid the mountain.
Start a hard turn, and we would do that. So my truck.
And this is all happening quick?
Very quick. Well, we would typically fly between 420 and 480 knots of ground speed. How
many miles an hour?
420 is 7 miles a minute.
Okay.
Or between 7 and 8 miles a minute is what you're flying.
That's fast.
At night. I mean, I broke out of clouds. I mean, I remember him and I flying. We were on its IR, it's called an IR route, an instrument route that's low. They're all around the country. There's the IR 344 that we used to fly, which would coast in off of Oregon. You'd fly from the land, you go out over the ocean, turn around, and then you could practice actually coming in on a coastline. And we were flying, and we ended up in the clouds. Keep in mind, we're between 500 and 1,000 feet in the mountains, and we're in the clouds. Like, you can't see anything. And I had to turn off our red lights that flash. They're called the anti-collision lights. Mm-hmm. Because it was reflecting off the clouds, and it starts to bother you. It just gets annoying. So I turned it off, and we're flying. We break out of that coastal marine layer, and poof, we break out. And it's a decent night. And this is right by Mount St. Helens. This is kind of where we're coming in. So we're coming in from the east, and we're just north of Mount St. Helens is where the route goes. And you look up, because you can kind of see the silhouette of this mountain that's right next to you. But you're flying along. You're just like, you got to trust. And you can see houses. You can see the lights. They're above you. We're literally below people's houses flying down these valleys and stuff. So just incredible experience. So when you take that and then you move into an F-18F. So now we're into modern technology that was actually built in this century. And you're flying. So now, the Wizzo is behind us, and we're not doing those night low levels, but that same type of crew coordination that has to happen, because what you're doing is you're sharing the load. So most of the communications that go out of the airplane, the Wizzo does all the talking. He uses his feet. That's the weapon systems operator in the back of an F-18F. So he's going to run, the radar kind of runs itself now, but we have a situational awareness display, and it's linked to all the other airplanes.
Just out of curiosity, what's the situational awareness display? Because that term comes up a lot.
Think of it as a God's eye view. So if you have the back of the Super Hornet the Block 2s has about an 8x10 display for the Wizzos, that they can look at. The pilot's is smaller. It's down between it's a 6x6 between his legs, and they're getting ready to redesign that. Boeing is. But when you look, it'd be like if you put your airplane and you're looking down. So all the stuff, like if your radar's seeing bad guys out in front of you, it'd be like looking down going, oh, I'm right here. And no, there's bad guys out here. And my wingman is over here. And it shows everything. It's just like, it gives you can look at that display and go, oh, okay, I can see where everything's at. I can see if one guy's trying to target another guy. It shows you all this. It's an incredible amount of knowledge that comes up for the crews to maintain the overall picture of what's going on.
The big picture sense of what's going on.
Because it's happening so fast. And this is that autonomy piece. This is the third brain. So we're all looking at it, and the third brain is doing fusion. It's pulling stuff together, going, oh, this is all this guy, this is this guy, this is this guy. It's sending it out through the link. So all the airplanes are talking to each other through this digital network, that we don't even see. It just says, that airplane says, hey, I'm over here. And it tells us, and we go, oh, he's right there. And then we can go, his airplane says, oh, I'm looking at this airplane, this bad guy. And it shows us, oh, he's over there and he's looking at this guy. I mean, it's an incredible amount of visual intake, because your eye, you can hear a lot, but when you look down at stuff, it's all, you can solve the picture really quick.
The third brain is doing the sensor fusion, the integration of the different sensors, and gives you a big picture view. What about the control? Like, is there, and I apologize as if this is a dumb question, but people use the high level term of autopilot. How much is there? Let's use a loose term of AI. How much automation is there? How much AI is there in helping you control the airplane?
The AI piece would be more of a control loop because of the digital flight controls. So the airplane actually, they had to make the airplane easier to fly. And when I say easy, it's relative, because people go, I could do it because I did it on flight sim. Real life is a lot different. In flight sim, you have no apparent fear of death. You'll do things on the simulator that you would never do in real life. But the autonomy in the airplane to allow you to manage, because you think about it, you've got a radar that's feeding you data, you've got a targeting pod that's feeding you data. All that stuff is hooked to your head because you've got a joint helmet mounted cueing system on that it basically maps the magnetic field in the cockpit so it can tell where your head's at looking. So if I turn my head to the right, the radar will actually look to the right, the targeting FLIR will look to the right. And oh, by the way, the back seater has a helmet on too, so he can look to the left and he can do things. So depending on what sensor he's controlling, so if he's got control of the targeting pod and he looks left, the targeting pod looks left. But if I have something where I want to lock a guy up that I don't see, that maybe the radar didn't see, but I can get over and now point the radar, because it's a phased array radar now, it doesn't really scan. There's all kinds of cool stuff that that technology brings. Because if you'd went back 30 years and said, hey, or 40 years ago and said, hey, we're gonna have this helmet and you're gonna be able to slew everything to your head. And I don't mean a mechanical setup, but I mean literally you're just gonna map magnetic resonance and go, oh look, and I can literally slew my sensors this fast, and then mash a button and transfer high quality coordinates from a system into a joint, a JDAM, which is a joint direct attack munition that is the GPS bombs that you see all the time, and then let that thing fly. And I'm solving this problem in seconds, vice minutes, or, hey, I got it. We're going to have to mensurate coordinates, and you bring back the data, and then they do all the targeting for it, and then they send another group out to get it. Instead of all that, now it's that fast.
So there's we probably don't have enough time to talk about the beautiful fusion of minds that happens when two people are flying, controlling the plane. But at a high level, this is a really interesting question for people who don't know what they're talking about, like me, which is, what is the difference between a human being and an AI system? Like, what is the ceiling of a current AI technology for controlling the plane? Like, how much does the human contribute? Is it possible to have automated flight, for example? Like, what is the hardest part about flying that a human does expertly that an AI system cannot? In warfare situations, in flying a fighter jet plane.
So I would say AI systems are usually black and white. When you write the algorithm for an AI system, it's basically you're taking thought and turning it into a giant math problem is really what you're doing, right? So you've got this logical math problem. Math problems are there's a line. It says I can or I can't, and it's a very finite line, but you can go up to the line. Where a human, we all have gray areas where we go, maybe, yeah, I'll try it.
So humans can operate within that gray.
So if you take an airplane and say, and I'll just take a Hornet for a while, a Super Hornet, doesn't matter, any airplane, and you go, here is the flight performance model of the airplane. So if you know what an EM diagram is, the energy. So it basically says the airplane can fly as slow as this, it can go as fast as this, it can pull this many G's, force of gravity, so 1, 2, 3, 4, 5, 6, 7. And then based on the airfoil design and everything else and how it can pull, here's how it's going to fly. because it's really physics based. Well, depending on how you write the AI, but typically AI, you don't want the airplane to leave controlled flight, right? You want to maintain it so that it is flying in a controlled envelope. Where there are times, and you can go back to World War I, where people intentionally departed the airplane from controlled flight in order to obtain an advantage, that's where the human goes, can I do this? I know it's outside of where I would normally go, but I can do that. So you can do some crazy things now, especially since the flight control logic in modern airplanes with digital flight controls, they're extremely forgiving. So you can literally, I've done things in Super Hornets that literally, even as a pilot inside the airplane, you're just like, wow, I cannot believe it just did that. Like it'll flop ends, which defies most logic. And I guess in a way you could probably program it, but I still think that when you get to the edges that may or may not give you an advantage, there are things that a human will do that AI won't. And I don't think we've got to the point, because how do you map illogical solutions? Most AI is logical. It's based on some type of premise. When you write the algorithm to control it, there's bounds.